Okay, so here's a challenge. Prove that the interior angles of a triangle add up to 180 degrees using nothing but Euclid's postulates and deductive reasoning.
So here are Euclid's postulates. We only need two of them actually to meet our challenge today. The first one, a straight line segment can be drawn joining any 2 points. And the last one, which is also known as the parallel line postulate, and we're going to explore that one in detail in just a bit.
But first, let's start with something very simple. According to the first postulate, we can draw a straight line segment connecting any 2 points, A and B, shown here. We can choose any point along that line segment. Let's call it X. In addition to Euclid's postulates, he had a handful of definitions. Here's an important one. This is the definition of a straight angle. So angle AXB is a straight angle. We can even assign a number to a straight angle, and the convention is to say that a straight angle equals 180 degrees.
Now we can draw another line segment through X in such a way that it bisects angle AXB, and therefore angle 1 and angle 2 must be equal by definition of bisection.
Now, of course, Euclid often has to use addition, and he takes it as obvious that angle 1 plus angle 2 equals our straight angle, angle AXB, which is 180 degrees. This leads to another definition, that is, a right angle equals 90 degrees, or 1/2 of a straight angle. Now let's go back to our line segment AXB, and let's draw another line segment through X, but this time let's say that the new line segment does not bisect AXB. We now have two angles, 1 and 2, where angle 1 does not equal angle 2. Euclid took it as obvious that when you add angles 1 and 2 together, you still wind up with a sum of 180 degrees. Now, let's go back to our triangle ABC. Let's remove line segment BC for a moment. And let's draw a line segment through B that is parallel to segment AC.
So let's return now for a moment to the fifth postulate, the parallel line postulate, which says that if two lines intersect a third in such a way that the sum of their inner angles on one side is less than the sum of two right angles, then the two lines must inevitably intersect each other on that side if extended far enough.
So here are two black lines intersected by a third, the blue line, and if angles 1 plus 2 are less than 180 degrees, then these two black lines must intersect at some point, and here they are intersecting. There is an important corollary to this postulate. That is, if two lines that are parallel, that is, they never intersect, and they intersect a third line, then the sum of their inner angles on one side must equal two right angles, or 180 degrees. Now we can go back and complete our proof. Because we've drawn a line through B that is parallel to AC, we know that angle 1 plus angle x equals 180 degrees, based on the parallel postulate. So let's put that little fact, that equality, in a black box over here on the right. And let's reinsert line segment BC, and we can see that angle x is the sum of two smaller angles, 2 and y. So we can say that angle 1 plus angle 2 plus angle y equal 180 degrees. Now we can label a third angle, shown here, angle Z, and because this line segment through B is a straight line, angle Z plus angle 2 plus angle y must equal a straight angle, which again is 180 degrees. So let's put that equality in a black box also. I've moved those two equalities up here so they are in a position where we can do a little algebra. Let's say we want to subtract the second equation from the first equation. You might already be able to see that angle 2 and angle y will be eliminated if we do that subtraction. I've rewritten them here so you can see that more clearly. When we subtract the second equation from the first equation, we wind up with angle 1 minus angle z equals 0 degrees. In other words, angle 1 equals angle z. Let's put that equality in a little black box. And let's go back and think about angle 3. First, we note that we can add angle Z to angle 2. And using the parallel postulate once again, we can say that angle Z plus angle 2 plus angle 3 equals 180 degrees. But we've already shown that angle Z equals angle 1. So, using substitution, we can now say with absolute certainty that angle 1 plus angle 2 plus angle 3 equals 180 degrees, and our proof is complete.